So Kaspa launched on November 7, 2021, and here's what makes that launch significant. No Premine, no pre-sales, no allocated coins to insiders. This was a true fair launch in the spirit of Bitcoin. The name Kaspa comes from Aramaic words meaning silver and money, positioning it as digital cash for everyday transactions while Bitcoin serves as digital gold. Now, the protocol uses proof-of-work consensus, which immediately sets it apart from the parade of proof-of-stake chains that dominate headlines. But here's where it gets interesting. Kaspa doesn't use traditional blockchain architecture. It uses BlockDAG technology, and that distinction is absolutely critical to understanding why this project matters. Traditional blockchains like Bitcoin and Ethereum process blocks sequentially, one after another in a linear chain. This creates a fundamental bottleneck. Bitcoin maintains slow block creation rates specifically to prevent orphan blocks that happen when network propagation delays cause miners to create competing blocks at the same height. Those orphan blocks get discarded, wasting computational work and creating inefficiency. Kaspa's BlockDAG structure solves this by processing multiple blocks simultaneously and incorporating all of them into the ledger. Instead of discarding orphan blocks, Kaspa links all sidechains together and uses a novel algorithm to order them correctly. This means parallel block creation instead of sequential, and every block produced by miners contributes to network security instead of being thrown away. The current mainnet operates at 10 blocks per second following the Crescendo Hardfork that activated in May 2025. That gives Kaspa confirmation times around 10 seconds and transaction processing rates between 3,000 to 4,000 transactions per second. And this isn't theoretical throughput. This is live mainnet performance happening right now. Now you might be saying, okay, but how does Kaspa prevent attacks if blocks are being created in parallel? Doesn't that create security vulnerabilities? And that's exactly the right question to ask, because this is where the GHOSTDAG protocol comes in. GHOSTDAG is an extension of Nakamoto consensus, the same security model Bitcoin uses, but modified to work with BlockDAG architecture. The protocol classifies blocks as either blue for well-connected honest blocks or red for blocks that might be malicious or poorly connected. This classification system ensures consistent ordering while maintaining security against 51% attacks. What's brilliant about this design is that it preserves Bitcoin's security guarantees while dramatically increasing throughput. Kaspa maintains the same level of decentralization and attack resistance as Bitcoin, but processes transactions orders of magnitude faster. The trade-off that most blockchains make, sacrificing decentralization for speed, doesn't exist here. Benefits include reduced mining variance, meaning smaller miners can participate profitably without joining massive pools. There's also a balanced fee market where even low-fee transactions get included during periods of lower network usage. When capacity utilization sits around 11%, transactions process quickly regardless of fee levels. Alright, before we dive into the Crescendo Hardfork and what it enables, I need you to smash that like button if you're learning something new about Kaspa's architecture. Drop a comment letting me know if you're mining KAS or if you're considering adding it to your portfolio. And, make sure you're subscribed with notifications on, because we're covering layer 1 blockchains that are actually shipping innovative technology, not just promising it in white papers. Let's keep going. So the Crescendo Hardfork activated on May 5, 2025, and this represented a massive technical milestone. The upgrade involved a complete codebase rewrite from Golang to Rust, known as Rusty-Kaspa. This rewrite was initiated by former DAG Labs developer Michael Sutton and developed by a global team spanning over 16 countries. Rust implementation enables record efficiency and industry-leading performance. Full nodes have successfully run on Raspberry Pis, decade-old laptops, and even mid-tier mobile phones. That level of accessibility for running a full node is, honestly, unprecedented for a blockchain processing thousands of transactions per second. Key changes from Crescendo include increased throughput to 10 blocks per second, expanding capacity while keeping costs low and maintaining security. Payload support was added so users can now attach data to blocks, opening up possibilities for smart contracts and applications beyond just basic value transfers. The hard fork enables arbitrary applications. Developers can now build DeFi tools, traditional finance integrations, DAOs, games, and identity systems on Kaspa, additive addresses and covenants through KIP10 support microtransactions, and advanced scripting for programmable payments. Additional KIPs, specifically KIP 4, 9, 13, and 15, improve efficiency, fairness, and scalability across the network. Since activation, the hard fork has operated smoothly, promoting miner decentralization and making solo mining more viable. Network hash rate has risen consistently, reflecting growing participation from miners worldwide. Technical innovations. Now also, Kaspa's implementation includes several technical features that position it for long-term scalability. Reachability provides advanced query capabilities for DAG topology. Block data pruning enables efficient data management with block header pruning, keeping node requirements reasonable even as the chain grows. SPV proofs allow simplified payment verification for lightweight clients, meaning mobile wallets can verify transactions without downloading the entire chain. Sub-network support lays foundations for future Layer 2 solutions. Cryptographic receipts provide verifiable proofs of transaction acceptance. And the harmonic mass formula solves state bloat attacks that plague other high-throughput chains. With this enhanced performance baseline, Kaspa is uniquely positioned to handle ZK rollups, enabling a diverse Layer 2 ecosystem that inherits Kaspa's security, censorship resistance, and MEV resistance while ensuring L2s remain tied to the main chain. The development is 100% open source, with code available on GitHub. Contributions come from a global team spanning more than 16 countries, with transparent development processes and community input. This open approach totally aligns with the decentralized ethos that drove Kaspa's fair launch. Tokenomics and distribution. Let's talk tokenomics because honestly, this matters for understanding Kaspa's long-term sustainability. The max supply is approximately 28.7 billion KAS. The current circulating supply sits at 26.51 billion KAS as of July 30, 2025. The emission schedule halves once per year, with smooth monthly reductions by a factor of 1/2 to the power of 1/12. The current block reward is about 4.9 KAS. Fair mining evolution started with CPUs, expanded to GPUs and FPGAs, and now includes ASICs. So, analysis of token distribution shows a remarkably balanced ecosystem. Over 70% of addresses hold between 0.01 and 10,000 KAS. Mid-sized wallets holding 1,000 to 100,000 KAS contain roughly 30% of the circulating supply, which, really forms a strong community foundation. Large wallets holding 10 million plus KAS control about 43% of supply, notably lower concentration than comparable projects where, often, 20 addresses control over 50% of total supply. Only 17 addresses hold more than 100 million KAS, representing 22.5% of supply. These are likely exchange addresses, indicating healthy distribution at the top rather than insider concentration. So, here's my take. Kaspa represents a fundamental advancement in blockchain technology by addressing core limitations that have constrained cryptocurrencies since Bitcoin's inception. By maintaining security and decentralization principles while dramatically improving speed and throughput, Kaspa delivers on the peer-to-peer electronic cash system vision described in the Bitcoin white paper. With 10 block per second operation right now, 10-second full confirmations, ZK rollup support coming online, and an open-source development approach, Kaspa provides technical infrastructure needed for cryptocurrency to achieve mainstream adoption for everyday transactions. The Crescendo Hardfork just activated successfully, and future projections target 100 blocks per second as the Rust implementation scales further. So with that being said, I hope you guys found this breakdown valuable. If you did, definitely leave a like, subscribe, turn notifications on because we're covering proof-of-work innovation that's actually shipping instead of vaporware promises. You guys are more than welcome to follow me on Twitter and join the free Discord in the description below for daily discussions on projects like Kaspa that are pushing technical boundaries. And before you leave, check out my latest video where I compare the top 3 proof-of-work blockchains for 2025. I guarantee you'll discover at least one project you haven't considered. And with that being said guys, it's been TJ from TJ Crypto World. Thanks for watching. Peace out.